Uh, Today we have estimating parameters for binomial, Poisson, and normal distribution. If you remember in previous exercise, we used to do all these testing or to find out, p-value, either there is a binomial or Poisson or normal distribution. So in that case, the parameters are usually given in the question. Means for binomial distribution, number of trials and probability of success will be given in the question. Similarly, for Poisson distribution, average or the parameter will be given in the question, and similarly for normal distribution. These are for a normal distribution, mean and standard deviation that would be given in the question, right? So, but if you look at this one, sometimes whatever parameters are given may not be fit as per the data, set of data is given in the question. So in that case, those parameters are known as arbitrary parameters. So in that case, we can say mm, the result or conclusion, whatever we are getting, may have little error or may not be exactly correct in that situation. So here in this exercise, we will learn if we have a set of data. So it's better first of all find the parameters for the data. Parameters means uh, we have to find out for binomial distribution if there is set of data, so we can see what is the n, what is the probability of success in the context of the data given. Okay, in the context of data given only, right? Similarly, for Poisson distribution, we can find out the average or mean value of data first, and then we can perform the hypothesis testing. And similarly, for the normal distribution, we can find out the mean and standard deviation first, and then we can perform the hypothesis testing. And all this you can do with the help of calculator. How to use calculator. I mean, your graphic GDC, graphic display calculator, to find out mean, standard deviation, and yeah, for other things, right? So we will use this concept when we have to find out parameters first and then perform the test, right? So we can look at the question here. This is I have written this question number, yeah, 2. It's a question number 2. In question number 1, if you look at in question number 1, so in question number 1, mean is given, right? Mean is given, and for okay, so use the data to estimate standard deviation. So you can find out the standard deviation, right? Here mean is already given, so we'll use this mean, but standard deviation is not given, so we will use the GDC to find out standard deviation first, and then we will do the okay, then we have to find the expected frequency. We know how to find out expected frequency. So expected frequency means probability times the total number of outcomes. Like here, I think 400, right? So this you can do, and then okay, then we have to perform goodness of fit test GOF. Okay, at 5% significance level. So you can do it easily. Okay, so here only one thing you have to find out standard deviation, and mean will remain for 1200, right? 1200. But so that's why I'm not taking that question, because that you can do yourself. Only one thing you have to find out. If you look at the question number 2, the number of boys in 100 families with 3 children is on the table. Okay, number of boys, no boys, 16 families. 1 boy, 29 families, 2 boys, 32 families, 3 boys, 17 families. Okay. Statistician wishes to check whether the probability of a boy being born into one of these families is always the same, and the gender of each child is independent. All the others, so he decide to test for a binomial distribution. Okay. So I have written this table over here. Then we have to find a probability, then expected frequency. I'm just making a complete table. So first of all, guys, what I do, I using this number of boys and observed frequency, I find the mean, okay, the mean, and I think you guys know how to find out mean for this one. And once I find the mean, I write mean over here. And what is the formula of mean for binomial distribution? NP. N means number of trials, P means probability of success. So NP equals to this much, N equals to 3 because there are 3 families. Sorry, 100. There are, okay, 3 children because, right? With the 3 children, yeah. So 3 and the probability of success will be this much and degree of freedom will be number of cells. Oh yeah, here the new things we will study when we have to estimate parameter. In that case, the probability, sorry, degree of freedom will be the number of cells, like 1, 2, 3, 4 cells, 4 minus 1 and 1 extra minus you are doing, right? So that's why normally what is that? Normally, if we do not estimate parameters first, I mean, when parameters are already given in the question, in that case, we have to do simply r minus 1, right? But here, or n minus 1. So, but here one more one you are subtracting in case of estimating parameters. So this is 2, right? Now, as you can see here, this is the, okay, I'm showing you here how to find out the mean. This is the manual method. But yeah, this is for question number 3. Sorry. Okay. So now once we get the mean, right, and then probability P we are getting, and then we perform a test, binomial distribution, and then we find the probability. Okay. So I will show you. No problem. I will show you this thing. So stat, you will open the stat part in your GTC. So in list 1, you will write the variables, I mean the subject 0, 1, 2, 3. In list 2, you will write the frequency. Okay, this is for finding a mean. Okay, so then you will calc. Okay, what you have to calc? One variable, right? We are okay, one variable. But before finding the mean, you just check the set. Okay, one variable list 1, one variable frequency list 2. Sometimes we put 1 over here when we don't have given frequency, but you have to be careful if you have frequency. So in list 2, one variable frequency, you have to check the setting. Okay, so setting our calculation for me is absolutely correct. I'll go back. I'll hit F1 for one variable. So you can see the X mean is 1.5319. Okay, all the things will be there. Then summation of X, summation of X square, right? It's a standard deviation and mean, minimum, quartiles, everything would be there, right? Okay, so let's, so okay guys, so in part B we have to perform hypothesis chi-square GOF test. Okay, so what we have to check, the data fits a binomial distribution where n equals 3 and probability of success is 0.5106. Okay, and H1 will be does not fits. Okay, this uh, does not fit does not fit. Okay, the data does not fit a binomial distribution, this, right? So list 1 you will write the observed frequency, in list 2 you will write the expected frequency. So this I have already find out here, once I get the frequency over here, and we have 100 families, so I multiply probability by 100, so I will get the expected frequency, right? So if you see the calculator, I have uh, in input all the values in list 1 and list 2. So let's go to perform the test. Okay, so we have test. Okay, test, we have chi-square test, we have GOF. Okay, degree of yes, freedom is 2 is correct. Execute. So p value we are getting, so you can write both when the test is being done. So you can see here chi square equals to 5.228280. Okay, 280, and p value equals to 0.0732, right? Okay, so 32 are writing this, or if you wish you can write this up to 3 significant figure also. Okay, so is it fine, right? So chi-square, let's because in the question we have given significance level, not the critical value, and alpha equals to 1%. 1%, alpha equals to 1%. 1% means 1 over 100. 1 over 100 means 0.01. Okay, so here you can see, uh, here this one. I mean this p value, right? This 0.0732 is greater than 0.01. Okay, so yeah, p value is greater than, so do not reject. So what will the conclusion? Do not reject. Okay, do not reject H0. Okay, so do not reject H0 means what is the interpretation of this result in the context of this question? So in the context of this question, H0 is correct means the data, whatever data is given in the table, it fits a binomial distribution where the number of trial is 3 and probability of success is 0.5106. So let's look at the question number 3. This question is based on the Poisson distribution. The number of fish per day caught in a lake by each angler is thought to follow a Poisson distribution. To test this belief, the number of fish caught in an hour by 80 anglers is recorded, and the results are shown in the table below. Okay, number of fish 0, 1, 2. Okay, until 6 and more than 6. Frequency 7, 10, and all, I mean the day observed frequency um, are given over here, right? So given that the maximum number of fish caught by an angler was fixed, find the mean of sample. So I think you know in question number 2 we discuss how to use calculator to find out the mean. So use your GDC to find out the mean. Okay. Using this mean as an approximation for the population mean, perform chi-square goodness of fit test to see if the observed values are consistent with the data coming from the Poisson distribution. So your first task is to find out mean. Once you find out the mean, then you will be able to find out the probability for this one, then expected frequency, and then you will find out the you will perform this chi-square goodness of fit test. Okay, so use calculator to find out mean for this distribution. So okay, now see mean we have to find out here. Now this is 2.8 and this number of is given, this observed frequency is given. So what I will do, I will show you how to use calculator. Now how to use calculator, right? So for Poisson distribution, press F5. There is a Poisson PPT. Okay. So what you have to write, first of all, we have variable 0, then 1, 2, 3. We have to find out until 6, right? So parameter is 2.85. This is estimated parameter, right? You write 2.85 here, then execute. We are getting this is 0.0578. Okay, so you write this value over here, 0 578. Right, you can write this up to 3 significant figure. Most of time we used to write this 3 significant figure, or in otherwise probability we used to write up to 4 decimal places. You can choose either one, right? So now this is similarly you will look for the one. Here you go. This we have already done in the class, how to find out the right probability for the Poisson distribution. So this is 1.1649. Okay, it will be 0.1649. Okay. Similarly, you can find out the probability for other variables, means 2, 3, 4, 5, and 6. Okay, so we have got all the probabilities, and now we have to find the expected frequency. So as you can see in the question, there are 80 anglers. Okay, so total outcomes are 80. So we have to find out expected frequency, So total outcomes 80 times this probability equals to 4.624, right? So here we can write this as expected frequency. Okay, this will be 4.6. You can write this, right? 4.6. 4.6 will be the first entry of expected frequency. Similarly, you can do 80 times this one, and whatever is the product you can write over here. So this is the data of all the expected frequency, right? Now, as per the question, we have to perform GOF, goodness of fit test, right? We have to perform. This was part A, and right, this was part A, finding mean. In part B, we have to perform test. So we will have to write the null and null and alternative hypothesis. So you need to write H0. So H0, what using this mean and approximation for the population perform chi-square test. So means this data, okay, the number of fish, or you can write the number of fish, yeah, or the data, or you can write the number of fish, okay, number of fish, right? Caught, number of fish caught, uh, can be modeled by, can be modeled by, okay, can be modeled by Poisson PO, and it's 2.85. Okay, Poisson distribution with this parameter, and alternative hypothesis cannot be, simply, right? The number of fish caught, the number of fish caught, sorry, fish caught cannot be modeled by Poisson distribution, right? PO and 2.85, right? So we will perform the chi-square goodness of fit test. So because since exercise 14L we are using this one, so it's easy. So perform this one and then find out the p-value. Degree of freedom you need to find out here. So it's better to write the degree of freedom. Degree of freedom. So degree of freedom means just check how many rows. 1, 2, 3, 4, 5, 6. Right. Okay, but yes, guys, there is a problem here. If I look here, we cannot directly perform the test until if you look at this value, this is less than 5. Okay, this value is less than 5. This value is less than 5. So if any value, any expected frequency is less than 5, so we need to combine that one to the next, or maybe previous, right? But since it's first, so it will be added with the second one. Okay, second one. So to make the uh, new row, right? Because it's 5. So here you will add all. So it will be, if I wish to write here, here number of fish will be 0 plus 1. So it will be 1 then, okay? 0 plus 1, right? 0 plus 1. Then 7 plus 1, it will be 70, new value. Similarly, you can add this one also. You can use calculator to add this one and this one also. Add these two, right? And right over here, add these two also, this two and this two, right? Like we have added these two values. So then there will be one, two, three, four, five, six. There will be six rows. So 6 minus 1 minus 1. So the degree of freedom will be 4. So guys, you will have to make a new table. Okay. First, you will have to add first and second. And remaining things, remaining tables, I mean, rows will remain same because their expected frequency is more than 5. Okay. So make a new table and then perform chi-square GOF test, right? And you will get the p-value. And let's check what is the p-value. So you can see p-value we are getting. This is 0.676, and see the significance level in the question. Okay, check the significance level. Let me see whether significance level is given over there. Significance level is not mentioned in the question. Otherwise, it should be mentioned. If not mentioned, you assume it's 5%. 5% means it's 0.05. So this p-value is greater than, so do not reject. Okay, do not reject H0. So it means what is the interpretation and conclusion in this context. So in this context means the number of fish caught can be modeled by this Poisson distribution where the parameter or the average value is 2.85. Okay, so I think you would have understood. So guys, this question fourth we have based on normal distribution. So if you read this question, the weights of grade 9 children are thought to be normally distributed. The district nurse uh, weighs 200, grade 9 is 10, and her result are in the table. So we have, if weight is 40, right? Wait, this is 40 is less than equal to W, W is less than equals to 45, then 12, 45 to 50, 59, 52, 55, 52, and 50, I mean this, you can see the table over here, right? Find the mean and standard deviation. So I think you know how to find out mean and standard deviation for this one. In this case, you need to find the midpoint of this, right? 40 plus 45. Find the midpoint of each one, and then list one. It will contain list one and frequency list two, and this way you can find out the mean. Okay, mean and standard deviation. We will need two things: mean and standard deviation. So how will you find out the mean? You will add both. I'll show you here. Wait a moment. To find out mean, we need to find out the x value. Okay. For the calculator in list one, we need to fill the x values. List two, in list two, this will be the f, right? This will be, so f is given, f frequency. So how will you find out this one? You will write 40 plus 45 and over 2. So this becomes 42.5. Okay, 42.5. Similarly, you do this one. You do next one, 45 plus 50. This is 95. Okay, 95 over 2. You write 95 over 2 gives you 47.5. Okay, this gives you 47.5. Or similarly, you can see 52.5, then 57.5, then 62.5. Okay, you will put this value in calculator in list 1 and list 2, and I have already told you how to find out the mean and standard deviation in the previous questions, so there you can check. Okay, so once you find out this mean and standard deviation, you need to note down here, and now you can see the standard mean is 52.51, standard deviation is 5.15. This means unbiased. Okay, this is unbiased standard deviation. Okay, so you have to make a table for this one. So if weight is less than 45, okay, you will have to mention it. If weight is less than 45 here, and this is 45 to 50, right? This is 45 to W, this is 50, this is 50 to 50 to 55, this is 55 to W60, right? And if weight we have, next is, okay, so if 60, weight is 60 is less than equals to W, okay, six, this 60 less than, okay, so this is for less than, you can say this one, right? Okay, this one you can use this one. Observed frequency, you can write this is 12, this is 59, this is 52, this is 68, this is 9. Then we have to find out probability, use the GDC to find out the probability of each variable. So let's use the calculator. Okay, so we have to find out the probability. So if you look past this one, this is normal distribution, and NCD, look here. So first of all, if less than 5, less than 45, so it means in that case, the lower value, lower bound will be, you guys know this is, okay, this we will write, upper will be 45 because less than 45, and then its mean is 52.6, right? Okay, so this we are getting 0.7757. Okay, so this we will write probability equals to here 0.7757. Okay, similarly you will find out the probability for others, like if you look at this one for the second cell, the lower is 45, and the upper is 50, upper is 50, right? So it will be it's going to be 0.75, no, sorry, uh, 0.0274. Okay, 274. So this way you find out the the probability for all this one, and then expected, I think you know, in case of expected, because if you look, we have a 200, right? Total output 200. So this will be here, you will write 200 times this 7757, and whatever, this will be the first entry of expected frequency. Okay, so if we do this one, this is getting, you can see this one, and then on the basis of this, you may have to write the degree of freedom, right? You will do this yourself, degree of, I mean this table, right? I have taught you the way you have to write 1 2 3 4 5 5 minus 1 minus 1, this is 3, but provided be careful whenever you get the expected frequency. So if there is any expected frequency that which is less than 5, so it means you need to add that row with its maybe before and after, right? That depends on that row, right? So if all are greater than 5, so then no problem. Then this will be degree of freedom. And then how to perform chi-square test? You know how to perform. Write the first H0, null hypothesis, then H1, okay? And then perform chi-square test. We have already discussed how to perform chi-square test for GOF, goodness of fit test, okay? And then get the p-value, compare p-value with the significance level, and then you can take the conclusion whether H0 will be rejected or not, right? So today you have to complete exercise 14.